take a closer look at the syntax required to call a function. In general, the syntax for a function that does not return a value looks like this. You include the name of the function, then in parentheses, you include any arguments that are expected by the function. Some functions don't have any arguments and your parentheses might be empty, or you may have one or more arguments. If you have multiple arguments, you separate them using a comma. The syntax for a function that does return a value looks like this. You still have the name of the function, you still need parentheses, you still need to include all the arguments expected by the function. The part that's new and different when your function returns a value is that you have to capture that return value and store it as a result in your program. That way you'll be able to use that information that's returned from the function in future lines of your code. Now, you may still be wondering, why are these library functions so powerful? Let's think of some advantages of using pre-built functions, things that are written by somebody else. A function is basically a black box. As a programmer, you don't need to understand the inner workings of this function. You just need to know how to operate the function. If you know the information that the function requires, in other words, what to pass in as arguments, and you know what kind of response the function will create because you know that there is or isn't a return value to capture, then you're able to call the function, and you don't really need to know anything about what the code looks like inside the box. Functions promote abstraction in this way. Abstraction is the idea that you can use something without understanding all of its underlying details. And when you use abstraction, it frees up your brain to do more sophisticated problem solving because you don't have to worry about those underlying details. You're putting your trust in someone else that they've correctly created this function that performs some activity in your program and that it'll work well in your software as well. You use abstraction all the time, even though you might not think about it. For example, I love salty snacks, and one of my favorites is popcorn. I usually make popcorn in the microwave, which is a black box. Now, I don't know anything about how microwaves really work, but I know how to operate a microwave in order to create microwave popcorn. I have to input my bag of popcorn, and I need to press the right buttons on my microwave's interface to tell it that I'm expecting it to make popcorn. And then I know how to interact with the microwave to receive the output that I want to get. I know that I need to wait until it stops, and then I can open the front of the microwave to pull out my tasty snack. And you can see that it would be really unfortunate if we could only make microwave popcorn if we fully understood how a microwave oven works, heat up the popcorn kernels and make them pop. I would definitely not eat popcorn nearly as often if I had to understand all those details in order to create my snack. But through the power of abstraction, I just need to know what kind of information do I need to pass into that process and how to expect output from the process. I don't have to worry about all the inner details about how to create a microwave or why a microwave works well. I'm trusting another engineer to have correctly created that solution for me, and then I'm just able to use it and benefit from the solution. The same thing is true in code. You don't necessarily need to understand how to write every single algorithm on the planet. Sometimes you can trust another software developer to have created a workable black box, a function that you'll utilize in your code, and you only need to worry about what the upper level details are. What information should you pass in, and how will that function communicate with you to provide output? Let's go back and look at some of the functions that we saw earlier in this module. As we look at the functions, we can see that we were provided with some documentation. Documentation is provided in computer science libraries in order to tell programmers how to utilize functions. Function documentation generally includes a description of the function I've provided in your notes as a goal. It includes the syntax for how to call the function in Python. And sometimes it also gives you details about the arguments that are expected and the return value. Every software library has its own unique style. Often the standard library documentation provides a lot of details, more details than we might be interested in this course. And so rather than have you look at the standard documentation today, we're looking at some high-level documentation. As we examine each of the functions, think about what each requires as an argument and what each requires as a return value, and then how that impacts the syntax for calling or using the function. Let's consider the print function first. We know that the goal of the print function is to display information to standard output. And we know that the syntax for using the print function is the word print, that's the name of the function. And then there are parentheses that follow that. That's where we include all the arguments or input values that need to be passed into the function in order for it to work. In the case of the print function, the argument is the combination of literal or string values and variable identifiers that you want to display to the screen. And so our documentation here tells us that the function requires one argument. This function does not have a return value, and we can see that reflected in the syntax. We don't have to assign any variable the result of this particular function call. Instead, we just make the function call and carry on with the rest of our program. Documentation also generally provides some examples, and 3 examples are provided in your notes. We might call the print function using a string literal, or we might call it using a variable identifier as the item to print, or we might call it with a combination of literals and identifiers, like in the 3rd example. Let's look at another function. We've used the input function many times during this semester as well. Software documentation for the input function would describe the purpose of the function. We know that is to receive data from standard input. It would provide details about the syntax for using this particular function. Notice that the syntax for the input function includes a return value over here as part of the standard way of calling that input function. And so we know that this particular function returns a return value. We can see that in the documentation as well. It tells us that the data entered through standard input is what is going to be returned from this function. We also know that the input function requires an argument. It is the string of information that should be displayed to the screen to prompt the user to enter their input. All of this comes together in the example at the bottom of the documentation where it shows how to use this function. You would use the function name input. You would include the prompt as a string in double quotes as the argument to the function. And then the information that comes back or is produced by this function, we're saying to assign that value to the variable name. Let's continue looking at some additional examples. We saw the int example. We know that that can be used to change a string into an integer data type. And the syntax for doing that is to use the name of the function int. It does take an argument, the identifier of the string value that you'd like to translate. And it does produce a return value. We can see that because we have a value over here to the left of the assignment operator. That's where that return value is stored. Just for clarity, the documentation includes those details as well, explaining the purpose of the argument and also the type of return value that should be expected. In this example, we can see 2 different ways of using the integer function. For example, we might read data from standard input, and we know that the input function returns a string value. We just reviewed that above. And so we might store that result that the user enters as a string variable in our program. And then we might pass that string variable to the integer function to translate that value into an int. And we could store the integer result in another variable. Sometimes in class, we've abbreviated all of those steps into a single line of code. I just want to emphasize the fact that these 2 lines that read an input value as a string and then translate the input value to an integer do exactly the same thing as putting them all on a single line. It's just a shorthand way of writing it, where what we're saying in this second version is that we want to call the input function using the prompt, please enter a number. And then whatever return value the input function returns is going to be used right here as the argument to the int function. And then the int function is going to translate the value from a string into an integer and store the result in this return value on the left-hand side. So it's performing all the same steps that we did in the 2 lines above. It's just a different way of writing it. Let's also look at the length function. Our documentation here tells us that the purpose of the length function is to find the number of characters that make up a string. We can see the syntax example here, and the documentation that's provided also tells us that there's one argument to the length function, it's a string, and that the length function returns a value representing the number of characters in the actual string. We've seen examples of that in class. where we calculated the length of, say, somebody's name that they entered and found out how many characters were in that and stored that as the string length. We can also use the length function with list information. And so the goal in this case is to find the number of items that are stored in a list. And the call to the length function looks exactly the same. We still say len, that's the name of our function. Now we're going to pass in a list identifier, something that represents a list in our program. And it's going to tell us how many items are in that list. It shouldn't surprise us that the length function has the same syntax, regardless of whether we're working on a list or working on a string, because strings are really a special kind of list. They're a list where each item is an individual character. Our final example is the type function, and the goal of the type function is to find the data type of a particular variable. The syntax for it looks like this, where you use the function name type. It expects one argument that represents a string, and then it returns a result of return value that you have to store someplace. In this case, the documentation tells us that the argument represents the identifier of some variable, and the result is where we could store the data type that is returned from the type function. So you might remember earlier in the semester, we used the type function to determine the data type of some different variables in our program. We could type in things like, I'm creating a variable called number that stores a decimal value 3.5. And I'm creating a string variable that stores a character string name. And then if I ask the computer to calculate the type of str, my variable, it's going to figure out what kind of data type is associated with this value. And of course, it's a string. And so it's going to print a message saying the data type of string is, and then it'll list string because that's the data type associated with the string. In our second example, when we ask it to find the type of number, it's going to return the result float because it's a decimal value, and it will print out the data type of number is float. Suppose that I didn't know about a particular library function and I wanted to discover if there was a helpful function that's already included in the standard library that I can use to do something useful in my program. Like suppose I'm going to write a program where I need to test whether all of the characters within a particular string are numeric. If I wanted to find such information in the standard documentation for Python, I could search for the name of the Python library, which is docs.python.org. And then we're using version 3, and I want to look at the library. And then I want to know, is there a string function that checks to see if something is all digits? And I'm going to get several responses up at the top here. I happen to know that this first one's going to be the best result. That's going to tell me just what I need. I could read through this documentation and search for it to tell me about how to check to see whether a string data type is a digit. I happen to know that the thing that we're looking for is called isDigit, so I'm going to search for that to make this a little bit faster. And I find out that there is a function, it's called isDigit. It returns true if all the characters in the string are digits. That's exactly what I'm looking for in my program. So if I'm able to locate something like that in the standard library, then I don't have to go through the hassle of writing and testing an algorithm that performs exactly that operation. I know that in my program, I need to call that function using syntax that says the name of my string, like maybe it's str from the example above. And then I want to find out if it's all digits. And when I look at the documentation, it tells me that it returns true, the Boolean value, if all the characters are digits. So I know to expect a Boolean data type as my return value. So I'll say something like, assign to my variable Boolean result the return value from str.isDigit. The standard library is really powerful. We've only scratched the surface of the functions that are available to us. You're always welcome to Google for functions that are part of the standard library and use them in your projects in this course if you find something. If you do use a function that's not covered during class and you find it in the standard library on your own through your research, be sure to include a citation in your program by just including a comment that says something about how you found the information. So for the isDigit function, if I didn't know about it, I would put a comment in my program that says, isDigit is from this particular website, so that I give credit to the creators of the standard library for Python.